right, integrated math 3 students, we got our next lesson over this idea of geometric sequences and exponential functions, all of that. But we have, today is going to be the iMath 3 portion of what we're trying to get into. Everything we did last lesson should have been reviewed from iMath 1 or some class prior. So today we're moving into the new content that that we'll have to be doing. So let's go ahead and get started. Okay, so what I have on the screen here, we have what's called a geometric series. So I need you to make sure in your notes you draw a line. Let's separate this from what we did in the last lesson and title it with what I have here at the top, which is geometric series. Okay. I'm going to write a definition in a minute, but we're going to go ahead and work this problem here. This is example 1. Oops, example 1. Okay, so I'm going to pause the video. During that time, really all you need to do is write 1 and 2. Here's the sequence for number 1, and then you can just write this part here. So, and I'm going to underline that. So you'll write that. So find the pattern first, and we give you the sequence here, and then find the sum of the first 6 terms. That's what I'd like you to do. So I'm going to go ahead and pause the video and let you do that. Okay, so you've had time to work on this, and for your answer, you should have gotten negative 3,276. That's what you should have gotten from this. So in order for you to do this, the first thing you had to do was find the pattern, and you're going to notice that the pattern is multiply by negative 3. Now, how you could have done that, let me fix my spelling here. You could have taken this term divided by this term. We talked about finding the common ratio. That's what this is. This is the common, I can type today. It's a common ratio. And that's part of what we're going to need to be able to find throughout this, this topic with geometric sequences and these series that we're introducing. So the common ratio is negative 3, okay? That's what we'd be saying here. Common ratio is negative 3. So from number to number here in the sequence, I'm multiplying by negative 3 to get to the next one. So the first thing you had to do to answer number 2, it says find the sum of the first 6 terms. You had to find 3 more terms to complete this. So I'm going to copy and paste these in here. There they are. And then we add them all together. Every single one of these gets added. You ideally used a calculator for that. You could use a simple one like this. Hopefully you have your own TI-80 that you're using or something like that to get this done. Okay, but when you sum them all, this is what you get. And I want to congratulate you on completing your first geometric series. You did it. Okay, that's what a geometric series is. It's taking a sequence and adding them all together. So really what a sequence is we're changing these commas to addition signs. That's the difference between a sequence and a series, okay? So here I have a series of a geometric series. It's the pattern is it's times 3 to get from one number to the next, and then I combine them all. That's what a series is. We're going to go ahead and write down a definition. So in your notes, you can put, say, definition there, and we're going to go ahead and write this down. A definition of a geometric series is the sum of a sequence of terms that follow a rule, specifically a geometric sequence. The sum of a geometric sequence of terms that follow the rule for geometric sequence. I might get rid of that. We'll just put sequence. A series could be for arithmetic if we wanted it to. But in this case, we want geometric. Okay, it's just the sum of those. So we got another example. It's going to be quite a bit more difficult. Okay, let's go ahead and look at it. You're going to again copy down. This is example 2. Oops, move that down. Okay, so we want to find the pattern. Here we have another sequence, and I made this one more difficult. Okay, And we are going to have to find the sum of the first 9 terms after we get the pattern. So I'll pause the video. I want you to take your time, try to find this answer here. Okay, so you had time to work it. And this one took a lot of work. All right, it's a pretty annoying question. First off, you'll notice that there's not an obvious pattern. Like, just looking at this, we know it's geometric because I told you it's geometric, but what am I multiplying by every single time? Well, there's not really something that's obvious. It doesn't look like we're just dividing by 2 or dividing by 3. It doesn't look like any of that. So we really need to rely on that idea or that rule of we're taking the second term and dividing it by the first term. So to get the pattern, I want negative 45 divided by 54. If I'm using my Inspire, negative 45 divided by 54, it'll turn it into a nice fraction for me. A lot of people will probably like to turn it into a decimal. I would advise against the decimal here just because it's a repeating decimal. If it was a nice even decimal, that would be good to use. But the fraction is actually going to be a stronger way to display this. So we're going to put that. Can I put it as a fraction? I'll just do it like this, negative 5 over 6. So this is our common ratio. So we know that going from one value to the next here we have to multiply by negative 5, 6. And that's where that rule of just dividing the two numbers to get it is going to be way stronger than just trying to like look for the pattern, okay? So we really want to rely on that rule of division to get us this common ratio. So we're multiplying by that every time. Now, here comes the very annoying part. Oh my goodness, you had to multiply by negative 5, 6 a bunch of times. So in the calculator, that would look like this. Also, 75 halves. Now that we'd multiply that by, and you'd have to use parentheses, especially if you're using the TI 80 series. There's that one, and then we want to multiply that by negative 5 over 6 again, and we're just repeating this, and we're just going to keep going, and we would write these out. Now, I am going to use a computer because this is a very repetitive task, and we're going to have a faster way to do it. So I appreciate your efforts on doing this. So I'm going to show you something that I created. I made an Excel spreadsheet here. Let me zoom in. And so what this does, and what I have this doing, is it is going to generate these for me. Okay, so 7, 8, 9. I want to copy this. So you can see how I have this laid out. Our common ratio is going to automatically appear here, down here, as soon as I start typing numbers in. Okay, so we are going to start with the number 54. This isn't something you're going to do. I'm just showing you a way that you can use a computer to do this. Right now it says the common ratio is 0 because I don't have another number here. But as soon as I put in negative 45, it's going to start calculating it for me. So there's that decimal that we originally got. Now all I need to do to continue this is type in this little function here. I want this times this, okay? And you'll notice this is 75 divided by 2. Now I'm just going to extend this. Did that work? Yes. I think it did. So yeah, this is equal to this times this, which is what we want. We're continuing the multiplication here. Yep. Okay, but I'm not getting the value that I originally should have gotten. So something went wrong here. Let me pause and try to figure out what happened. Okay, so here's the issue. I didn't extend this all the way. That was the problem. So let me extend this. There we go. Okay, so this is the answer you should have gotten. 35.16. And you would have done all this by hand, presumably. So this is the answer, and we can round to 2 places because it says the nearest hundredth. But these are all the values that you would have gotten if you did it. And I used a computer to do it, which was way nicer. Okay, just a lot cleaner, a lot faster. So I'm going to put that in here. So there's all the values. And what we did was we wanted to add them all. We added all these values together. Let me shrink that down. Okay. So by hand, this is a very annoying task, and you won't have an Excel spreadsheet to do this. Also, some of you may not know how to use this, and that's fine. We're going to show you another way to do this. Okay. Here is the math reference sheet, and you'll have this on your next test because a lot of the formulas that are actually useful, really most of this is kind of useless, to be honest, and it has the different grades. Here's what you guys would get is this formula sheet. And so you have a lot of different formulas on here, and really this whole unit we're using a lot of these. So we'll be getting into this next lesson, compound interest and stuff like that. Here's what we need, okay? Here's the formula. So let's go ahead and in your notes, you're going to write down this formula, okay? Let's copy that down. I'm gonna put it in here. And this is what we want to set up, okay? Finite geometric series. Go ahead, I'm gonna pause and let you copy that down. This is the formula that we want, okay? All right, so you've had time to write down this formula. So let's talk about these parts in here. Okay, let me move this up. Let's talk about first this a sub 1. I'm not gonna do a subscript. I don't even know if I can. Symbol, I need equation. It's fine. So the a sub 1, I'm just gonna copy it. There we go. So we'll move this down here. A sub 1 is going to be the initial value or first term. So let's write that down. In this case, what is our first term? Well, it's 54. Next, we have n. We want a lowercase n, though. I'll fix all of this in a second. So n is the number of terms. So we'll write that down. How many terms are there? Well, there's 9 that we're interested in. Okay. And then finally, we have R, which is the common ratio. In this case, we figured out our common ratio was -5/6. Okay. So now we have all the information that we need, and we can actually set up this equation on here. I'm going to draw it. So let's go ahead and draw this. We start by putting S sub n here, which we know is 9. Okay. We set that equal to, well, first thing that we're writing is a sub 1, which we know is 54. Then we're going to use parentheses. We have 1 minus R, which is our common ratio, so -5/6 over, hold on, or to the nth power. N is 9. Close that parentheses. Then on the bottom, it's 1 minus -5/6. And that, we'll type that in, and we're hoping that we can get this answer here. We want that 35.16. So let's try typing this in. I've got my Inspire here. We're going to use this to do this. So, and I'll work this as if I'm on the 80 series. So if you have your 80 series calculator, you can use that. What I would do is I would start inside here. I would do 1 minus, I would do, if I'm going to use it in parentheses form, so those on the 80 series can do this pretty well, divided by 6, and we're going to raise that to the 9th power. So I'm going to hit enter, and it gives you a pretty wild fraction, but we're not really worried about that. We're going to go ahead and copy it. So you can use the directional pads on here. You can do this even with the 80 series. go up, hit enter to copy it, and we want to multiply that by this 54 on the outside. So what we found first was inside the parentheses, so we're going to multiply by 54. Changes the fraction. Now what we want to do is we want to divide this. I'm going to go up, copy, and divide it by, I'm going to use parentheses. And of course, I think on the 80 series, it's going to give you decimals, which is fine. You can just copy those. We want to divide it by the bottom. 1 minus, parentheses, -5 divided by 6. I'm going to go ahead and hit Control Enter so that it gives me my decimal. There it is. This is exactly what we got for our answer. It's highlighted here, 35.16. So we got that. We had gotten that on our first try with the actual summation inside this Excel spreadsheet. Okay, so this formula is going to be our new tool for solving these. It makes it a lot quicker because these can be pretty annoying. Let's look at Delta Math really quick. Here's the same types of questions. Now I want you to notice the formula they give you. They're going to have it there handy for you, and let's compare that to the one that we had. Let me copy this again. So here is the formula that Delta Math gives you, and here's the one that Tennessee gives you. And you'll notice they are exactly the same except for one little detail. This a sub 1 is only showing up out here. Here it's twice. This is what they did in Delta Math, was they distributed this into here, and that's what's causing this. We have just a common factor of a sub 1. We're not going to really dive into the origin of this formula or anything like that. It does work out mathematically, like the summation process of this is occurring throughout it. It's that repeated multiplication of this, starting with that first term, and it's just repeated over and over. So there is a way that it's created, but really we're just going to worry about using this formula. So don't worry about the one that's in Delta Math unless you really just want to for some reason. You can, but let's go ahead and work this problem. So the first thing we want to do, we need to make sure that we find the first term. Well, we have that, 324. I'm going to go ahead and pull up my calculator. So watch the fast way that I'm going to do this to make this a lot easier, okay? I'm going to start my formula, and I'm going to do this pretty quick for the TI-80. I'm going to keep this up as well, okay, so that we can reference it. And I want to erase this. Okay, so we're going to start with the first term, this a sub 1 here. So we know that that's 324. I'm going to open a parentheses. I want to do 1 minus. To find the common ratio, I'm just going to do this. I'm going to use parentheses. I'm going to do 54 divided by 324. There's no real reason for me to actually find the common ratio at this point. It's just an extra step. If I want to, I can, but I'm going to go ahead and raise this to the, how many terms do we want? Well, it says first 6 terms, right? So I put a 6 here, and then I'm just going to repeat what's inside of that, except no more exponent. This will get me the right answer here. Again, I found the common ratio, R, right here, by just dividing this term and this term together. If I really wanted to see what that was, I could, but I don't have to for this problem. It's going to give me a big old fraction. For those using an Inspire, if you're on the 80 series, this will calculate itself, and that's fine. Hit Control Enter. There it is. And we round to the nearest hundredth, so 388.55 should work. Hit Submit. What did I do wrong? What? 324. I wonder why it's rounding so incorrectly here. I wonder what happened. Let me try this again. This time we'll do it their way, I guess. Let's do, this is 1/6. That's why I'm glad I do some of these examples on here so that I can spot some issues. 7/9. Why is that so different? It shouldn't be that different. 54. Maybe I made a mistake up here. 25. 24. Oh, that's the issue. Okay, I spotted it. 24. This is supposed to be 24. So let me go back and copy that, and that should fix it. Okay. I'm sure y'all were noticing that. For some of you that are very attentive, just gotta, I gotta scare you a little bit. All right, I'm gonna hit Control Enter. This is gonna give us the right answer. Okay, if you plug in the numbers correctly, you'll get the right answer. So that's how you'll do that. And then if you're using like an 80 series or an Inspire especially, watch what I'm gonna do here to answer this one. I'm just gonna go up, copy this. I'm gonna just change the values that I need to. These can go so fast if you have like an Inspire, or if you're 80 series, if you figure out the ways to copy it properly. This actually I should do -150 on top, 30 on the bottom. So it's this one divided by this one inside of my ratio. I'm going to hit Control C, copy it down here, Control V, repeated. There's 10 terms, that's in. That's gonna go here. I'm gonna turn that into a decimal. Now I'm getting a scientific notation, so, oh, I messed up. I didn't do this completely correct. I need to change this to 30. I'm going too fast, so make sure that you don't go this fast on yours, because you can see all the kind of mistakes that can happen. I would say write it out would probably be a better way to do this. I'm being a bad influence right now trying to do these so fast. But that should be the answer. Okay, got it. But make sure, take your time with these and write out the formula. I think that's going to be more helpful to avoid errors. You can see even me, somebody that's pretty proficient with the technology, making these mistakes in here. So writing out your formula each time, setting it up into this on paper, good idea, just to keep things very, very straight. Okay. On here, you only have 5 questions. I'm going to change that now to 6. You're welcome. And so that's just to get some practice with those. We're going to go ahead and look at the next skill as well. Okay. Okay. So we are going to talk about, so in your notes, I want you to draw a line, and we're going to do the sum of geometric series, but we're going to do it in a context. Okay, so what that means is word problems. You've got 10 of these, so there's quite a bit here. There is a help video that's attached with all these, so if you're confused after the lesson here that I'm giving you, make sure you go and watch that. Okay. So we are going to have to be using, so go ahead and in your notes title it Sum of Geometric Series in a Context, and these word problems. We're going to have to use, this is an iMath 1 skill here. This is exponential growth and decay. Now what's confusing about this is that we see R again, and right here and right here, but really this whole thing, those are the common ratios. Okay, let me type that. Common ratios are these values here, that arrow, and here, whenever we're creating this. So growth and decay is not super difficult if you remember to create. We only care about this blue part to this, and we're gonna read this question here. So in your notes, we'll put example 1, and you don't have to write this whole thing out. But of course, you can go back and reference this in the video, or go on my YouTube and look at it. But let's read the question. It says, a large company put out an advertisement in a magazine for a job opening. The first day the magazine was published, the company got 152 responses, but the responses were declining, that's a key word there, by 25% each day. Assuming the pattern continued, how many total responses would the company get over the course of the first 5 days after the magazine was published? To the nearest whole number. We want a whole number on this. So first off, we have to figure out what the actual common ratio is. We're still using this formula here. I'm going to enlarge it. I don't know if I can. We're still using this formula. I'll just wave it around. Our summation formula. So we need to find A of 1. We need to find N, and we need to find R. Okay. Now this is where things get confusing and kind of redundant. it seems, see how I have this red R here? This is not the same as that, okay? The blue, what I have underlined blue over here, the common ratios, is what's going to go over here for this R. So it's kind of weird how we're kind of doubling up on that. What I've underlined in red is the rate of growth or decay. Well, that is shown here. Okay, so if I want to find the common ratio, first off, is it decay or growth? Well, it's declining, so we know that this should be equal to 1 minus the rate of decay, which is 25%, but we got to put that as a decimal. So what that means is this is going to be 0.75. 0.75 is the rate of decay, or excuse me, the common ratio. We're multiplying by 0.75 each time. It's decreasing in the order. What is the first term? Well, what happened on the first day? Well, they got 152 responses. That's what we're interested in, is the responses. And then lastly, what is n? That's the total number of days that they want in this instance. They want 5. So we have everything we need to do the calculations. We just need to set up our formula. And this time, I'm not going to skip writing this out this time. So we want 152, and this is a series of 5 terms. 152, 1 minus, we have our ratio, 0.75. And again, I'm using, not that formula, I'm using this formula up here to help me. So I'll bring it down just so we can reference what we're looking at here. Okay. Raise that to n. N is 5. We know that. And then we want on the bottom, let me close that actually, we want 1 minus 0.75. So now it's time to get the calculator out. Let's move it over here. And let's set this up. I'm gonna make a fraction. 152 parentheses 1 minus 0.75 to the 5th. Make sure that you're typing this in appropriately. You may want to use parentheses around this here, just to really make sure that it doesn't mess up. And then we want 1 minus 0.75 on the bottom. I'm gonna hit enter. It should give me a decimal. Okay, cool. So we go over here, we'll move this back over, and we want to the nearest whole number. So we're gonna round this up, is what that means. And I think for any instance, any number, we're gonna round up in that case. So we're going to put 464. I haven't checked the answer on this, so let's see if we got it right. We did. Okay. So that's how you're going to want to work these word problems. You need to list out the terms, or list out the parts that you need, because all these are going to be series. So we're using this formula here to do it. We can't forget to find our rate of decay and growth, putting that into this formula here, or just in the blue part. That's all we need for this growth and decay. We just care about using the rate of growth or rate of decay, making the ratio, and then continuing. So you have a ton of different questions on here. A lot of these say declining here. Let's look at some more. She increases the number of miles by 10%. So that is a growth situation. So you're just reading the context to see what you need to do, okay? And a lot of these have the same context: salaries, running, music videos posted online. So that's what we're talking about here. I know this video is going pretty long here, but we do need to look at one more context. Actually, so what I'm talking about is this sigma notation. I'm gonna wait to do this one to the next video, just because this video is already so long. If you want to watch the help video, you can, just to see what it's about. It's gonna be using this formula more right here, this one, to help answer it. But we have to figure out what the heck sigma is. So we'll do that next time. We'll also start some compound interest in the next lesson. But I'll stop there with this today.